Okay, so let's pick up where we left off. In the last video we did number 12, so in this one, realize that this function, or this integral, could have been written as 1 over x squared dx from 1 to 2, in which case you would have wanted to write it like this first, because then we could use our rules. Now remember your antiderivative rules, so look them up if you need to, but this is a power rule, so we're going to make this x to the 1 higher power over that power, x to the n plus 1 over n plus 1, from 1 to 2. Now simplify that a little bit, that's just negative 1 over x from 1 to 2. And capital F of b means plug in the b value to the antiderivative, minus capital F of a means to plug that in, negative 1 over 1. And just simplify, so 1 minus a half equals a half. Graphically, just kind of remember what you're doing. 1 over x squared looks like this, and when we find the integral, we're finding the area between 1 and 2. So again, that area is a half. Okay, let's just do the antiderivative here. The antiderivative of cosine theta d theta is sine theta. Make sure you get your signs right. So sine 2 pi minus sine pi is 0 minus 0. Right? Because sine 2 pi is right here, sine pi is right here, and that's 0. So does that make sense? Think about the cosine graph. Your 0 to 2 pi has this much above the x-axis and this much below the x-axis, and they cancel each other out. Okay. Alright, next example. It's just raised to a power. So we want to say x to the 1 higher power. Now 3 sevenths plus 1 is 3 sevenths plus 7 sevenths. And that's over that power, over 10 sevenths, is the same as times 7 tenths. And then we go from 0 to 1. Well, it's actually not that bad, right? 1 to any power is just 1. And 0 to that power is just 0. So we have 7 tenths. Okay, number 18. This is an x to the 1 half down here. So to use the power rule, you can't leave anything in the denominator, so we have to rewrite the function first. So x to the 1 half on the bottom will be x to the negative 1 half up at the top. Okay, and now we can use our power rule. So x to the 1 higher power is positive a half over that power. If I put this x over 1 half, I multiply it by 2 over 1. Going from 1 to 4, 4 to the 1 half is the square root of 4, and 1 to the 1 half is the square root of 1. So that's 4 minus 2, or 2. And I have a check mark by number 20 because I'm not going to do this one with you. I just want to make sure you realize if you have a quantity raised to a power, you actually have to work that out first. There's no special rule like the chain rule. So you would have to turn that into a trinomial. What would that be? X to the 6th minus 2x cubed plus 1, and that's what you would have to integrate. Okay, in a function like 22, and I'm leaving these visible so you can also see 26, they're very similar in that they have a monomial in the denominator. When you just have one term in the denominator, you can simplify these, and you can simplify it in two ways. You can think about bringing this u to the 1/3 up to the top and distributing through this quantity and adding exponents. Same thing with this. You can bring it x to the 2/3 up to the top and distribute it through by adding your exponents. One thing I like to do instead is kind of think of this as 4 over u cubed plus u squared over u cubed. And I kind of just split it up like that, which is how I'm going to do the problem right now. So 4 over u cubed is the same as 4u to the negative third. And u squared over u cubed is the same as 1 over u. Now I'm tempted to write it as u to the negative first, but that's actually not going to help me. I think you guys would remember this integral more if I left it 1 over u. Right? Okay. So look at your formula sheet. And we're going from 1 to 2. So first let's get our integral. 4 times u to the 1 higher power over that power, and then plus the natural log of u, and we're going from 1 to 2. Now let's just simplify this part a little bit. We have a negative 2 and a 4, so that's just going to give us a negative 2 over u squared plus the natural log of the absolute value of u from 1 to 2. So let's plug it in our b, and then let's plug in our a and subtract them. Okay, so negative 2 over 2 squared plus the natural log of 2. Now I would put the absolute value in, but the absolute value of 2 is 2. Okay, minus a negative 2 over 1 squared plus the natural log of 1, same thing with the absolute value. Natural log of 1 is 0. Make sure you do remember that. So all I have left over here is just the minus a minus 2. So minus a minus is going to give me a plus. So this is a negative a half, right? So negative 1/2 plus 2 is 3/2. And then we have our plus natural log of 2, and that's the answer. Okay, so you should probably pause at this point and try to do this one the same way. Maybe you've been pausing all along. I guess I should have said that a few times already. Pause if you want to try it yourself. Okay, so I'm going to use those and these. I'm going to rewrite the integral, bringing that x to the 2/3 up to the top. So again, pause it if you don't want the answer until you get it yourself. Okay, if you need a little explanation here, x to the first over x to the 2/3, I like to think of canceling those. I'm going to cancel out all 2/3 of these with 2/3 of that, and I'm just left with the third at the top. Okay, so x to the 1/3 minus, and then this is just 1 over x to the 2/3, so it's x to the negative 2/3. Now let's integrate, so we have to use our power rule. X to the 1 higher power over that power minus x to the 1 higher power, negative 2/3 plus 3/3 is 1/3, over that power. And we're going to evaluate it from 1 to 8. Okay, so 3/4 times. Now your goal is to do this without a calculator. This would not be on the calculator part of the AP exam. Okay, so how do you do 8 to the 4/3 in your head? What you want to do is you want to take 8, you want to cube root it, and then you want to raise that to the 4th. Okay, 8 cube rooted is 2. 2 to the 4th is 16. Alright, next. 3 times 8 cube rooted. And then we want to put in the 1. 3/4 times 1 to anything is 1, minus 3 times 1 to anything is 1. Okay, so what can I do to simplify this? The 4 and the 16. So here I have 12 minus 6 minus 3/4 plus 3. And I'm good distributing my minus sign through. So 9 minus 3/4 is 8 1/4, but I think I want to think of it the other way. 36/4 minus 3/4 is 33/4. Again, you can turn 8 1/4 into an improper fraction as well. And that's your examples.